All right. So I assume that all of you saw the title of this talk and came because you are fans of the 2008 movie musical Mamma Mia. Yeah? Okay, could I get a show of hands who is familiar with the movie and feels like they could explain the plot to a friend or colleague? Okay, for everyone unfamiliar, which hopefully is very few of you, I will start with a brief overview. So Donna is the proprietor of a boutique hotel on a fictional Greek island. It was actually in Greece for the first movie. The second movie was set in Croatia, or like filmed there. It's kind of fun. She has a daughter, Sophie, who's getting married. Cute. We don't like the fiance very much. But isn't that always how it is? Here's the twist. Sophie wants her father to come to the wedding, but she's never met him, and Donna isn't sure who it is. It could be any of Bill, a travel writer, Sam, an architect, or Harry, who works in finance. Sophie invites all of them to the party, where they sing, dance, and experience a series of melodramatic twists that are narrativized by the lyrics of ABBA songs. And in the end, it turns out her real dad is, we actually don't know. There are theories, like lots of fan theories online, but at the end of the day, part of the meaning, the message of the movie, I think, is that it doesn't really matter, because they're all there to support her on her big day. But people do think it was Bill. Okay, it's a really nice story, right? I want to try telling that same story again, but this time it's about DBT. See, I am the lead of a data platform team. I am preparing a big report that will show off my most important data set. I need to trace the lineage back, but I'm not sure where it's coming from. And to make matters trickier, I work in an organization that has multiple data platforms. See, we use Databricks for data ingestion and staging, Snowflake for core data modeling, architecture, and data model design, and Athena for the finance team, for some reason. Maybe just in keeping with the Greek theme. So which one is my real dad platform? What if it doesn't matter? I already use DBT as a common framework and abstraction layer for defining, transforming, and testing and documenting, almost forgot that one, data models across all of those different teams. And since the introduction of DBT Mesh a few years ago, that's okay. I can reference models across projects just by writing ref. So if those projects existed on multiple data platforms, now I actually did have this idea, we all had this idea a few years ago when we were first building Mesh. It was kind of sort of possible. This is some screenshots of me from 2023. I feel like Anders remembers watching this Loom video. Databricks can write data to S3. Snowflake can read data from S3. As long as someone can pass the S3 path from one to the other, it kind of works. I used a custom ref macro to make this work. So remember, you can hack all sorts of things. You can even see the cross-platform lineage in DBT's catalog. It was a really cool hackathon project. It also did not scale well in practice. See, Databricks wants to write data in the Delta file format, and a few years ago, Snowflake had experimental support for Delta, but did not work super well for large data volumes. It also required a manual process to tell Snowflake anytime a new table existed, or when that table had new data. It's like alter table, refresh, yes, the new rows, please. Passing around S3 file paths is all well and good the first few times you need to do it. As soon as you are doing it a dozen or more, for a dozen or more tables, you're going to want a real metadata service that can keep track of which files belong to which tables, who's updating what, and when. So what you want is a catalog. Oh, there's the one I wanted to show. Who's heard of this? Okay. So since that hackathon a few years ago, data warehouses have taken steps to standardize on open table formats, and it seems like Apache Iceberg is the one that has the most traction and consensus in the ecosystem right now. Databricks acquired Tabular last year, the Iceberg company. Almost every major data platform now supports reading and sometimes even writing Iceberg tables. And the most important data platforms are adding support for Iceberg catalogs. Whoa, what does that all mean? Let's take a second. So, show of hands, who's heard of Iceberg before coming to this talk? Okay, keep your hand up if you are already using Iceberg in at least like production-ish today. And then keep your hand up if you feel like you can confidently explain how Iceberg works under the hood. Yeah, so it is fewer people. More people are using it than understanding it. But still, I do see more hands up than when we asked this exact same question last year, for those folks who were in the room then. And I actually want to hear from all of you about your real-world experiences using Iceberg at scale in production for whatever use cases. There's a roundtable that's a follow-up to this talk tomorrow. OK, let's just talk about it, though. What the heck is Iceberg? So similar to dbt, Iceberg is multiple things rolled into one. On the one hand, it is a table format with a metadata layer, a way of storing tabular data with the ability to track versions, schemas, and snapshots. This is what that looks like, at least a rendering of what that looks like. You have a whole bunch of data files all the way down at the bottom, like the Parquet files that I was manually passing around as S3 paths with my custom ref macro. But now you also have manifest files that keep track of versions of that table, called snapshots also in Iceberg. And then you have lists of manifests that know about all the versions. And then you have metadata files that track additional things like partitions on this table or other features that data warehouses can use to optimize their reads and writes. And finally, on the top of all of that, you have this thing that's called a catalog. So providers have used the Iceberg spec, like this standard way of laying out data and metadata associated with that data, to implement things called Iceberg catalogs, which is a pretty broad umbrella term that under the hood encapsulates a whole lot of different implementations and the complexities of those implementations. But each of them implements, by and large, a REST API for interacting with data and metadata. So just to reiterate this, the table's actual content is in the data, most often Parquet, most often some kind of columnar format. Iceberg isn't the file format itself. It's the way of representing the metadata associated with those data files. And this is kind of an interesting thing about Iceberg, is that the metadata and the data live side by side in object storage. S3, Google Cloud Storage, Azure Blob, what have you. The fact that they are co-located is really cool because it means that anyone who understands Iceberg, not like me or you, but like any query engine or data platform, gets to read this table as an offline operation. Like it doesn't need to hit some kind of server or API to find out about the table's existence or to get access to the latest version of that table. But it also introduces quite a bit of trickiness if multiple engines are trying to update that table at the same time. So we'll come back to that a little bit later. But just to say, all of this is the motivation for having a real Iceberg catalog, which is a relatively new warehouse or engine construct, providing an abstraction layer over all of these files and metadata files. The catalog exposes an API for read and write operations that it then actually goes and handles the updates to the underlying files. There are many different catalogs that all implement their own version of a REST interface over Iceberg. So managed catalogs like AWS Glue, Databricks Unity, Snowflake Open Catalog. Folks in the room who are using Iceberg, it's like, are you using managed catalogs by and large? Yeah, OK. There are also open source catalogs. So Polaris is the open source version of Snowflake's managed catalog. Lakekeeper is a very neat and relatively new company that also has their own open source catalog that implements the Iceberg spec. And you can host these yourself and extend them as needed. But then you can even build your own implementation of the Iceberg REST catalog spec. OK, all of that for what? Well, all of these catalogs provide read endpoints that let you ask questions like, which tables are available? What's the latest version of this table? What data files do I need to read to actually access that version of the table? Which data files do I need to answer the query I'm only interested in, if I'm only interested in a set of partitions of the data? Like, give me the total population of all Greek islands starting with S, real or fictional, and also the word count of all the lyrics in ABBA songs released after 1975. It also lets you do things like time traveling back in time to read an earlier version of the table. And this is important because the old data files are never actually replaced or updated directly. There's always new files that are added, and then new metadata files that track the row-level additions, deletions, or updates. Ideally, those are atomic operations. The new data is written to new files, and then that's it. We pop over to read the new version of the table. No downtime. But for busy tables, this quickly leads to a lot of small data files, a lot of small metadata files that track all the little update operations. And because Iceberg tables are merged on read, that is to say, only when I go to actually query this do I figure out where the heck all the data is and how to merge it all together, that can lead to some pretty slow queries on busy tables. So then, it's like I'm describing a cottage industry here. There's a whole other set of optimization and operations that need to be performed, things like partitioning and compaction, so that query engines can scan the fewest files of the optimal size just to find the data they need. Whoa, okay, maybe many of you are sitting here and thinking, that all sounds like stuff that data warehouses have been doing for like a long time for their own managed storage. And you are absolutely correct. You see, Snowflake, Databricks, and BigQuery have always stored the actual data in tables in blob storage, kind of similar to this. They do all of these things, reads, writes, partitioning, compaction, automatically and behind the scenes. Databricks stores data in Delta files by default. Snowflake and BigQuery have proprietary data formats. Snowflake calls theirs, I think, FDN, flocon de neige, pour le francophone dans l'audience. C'est vrai, Anders? Ouais, okay. Now, those data platforms also support writing tables in Iceberg format within their own managed catalogs. So you get all the benefits of a managed table, but now it's an Iceberg format instead of flocon de neige. Those are managed. The data warehouse takes care of the maintenance behind the scenes. It provides query performance that's almost as good as managed tables in the proprietary format. So if all you want to do is keep using Snowflake exactly as you do today and switch your DBT models from materializing tables in Snowflake's proprietary format to materializing tables in Snowflake's managed catalog in Iceberg, that's basically it, right? Kind of cool. So if your boss has given you a quarterly initiative of start using Iceberg, nice, right? That doesn't achieve my dream, though. You see, earlier this year, DBT introduced a concept of catalogs, which goes beyond just this one table in Iceberg format and extends out to many tables, all materialized as in Iceberg, with the possibility of using those tables across multiple data platforms. DBT Core 1.10 added support for a new project-level file, catalogs.yaml, and we just added support for this in Fusion as well in the last couple of weeks. So this file serves as an abstraction over how DBT writes tables to Iceberg. And this is useful in two ways. First, there's like a ton of configs here, and they vary based on the data warehouse and the catalog that you're using. So the DBT adapters each encode validation rules based on what's supported where, and this stuff is evolving really rapidly, so the catalog spec is quite fluid. But you get to define these things once in one place, and then each model can basically be as simple as this one was, except instead of a table type Iceberg, you can say catalog name and point it back to your catalog definition. Second, different Iceberg catalogs have different rules about how identifiers are named, quoted, and what kind of characters they can contain. So for anyone who has dealt with quoted identifiers on Snowflake before, seeing a lot of smiles in the room, this can be a real source of friction, and it's also an opportunity where DBT can help. Okay, so it's easier than ever to write DBT models for Iceberg. Again, for some of you, that's enough. But these tables are now in an open format, in blob storage, and theoretically queryable from outside of the data platform that you used to write that table. So I want to talk about my dream here. I need multiple data platforms reading and writing the same Iceberg tables in the same Iceberg catalog. Because if they're all my data platform, they should all be able to walk my data down the aisle. Nailed it. Okay, I think it's time to go to a demo. What do you all think? Oh, no. All right. So I have my Mamma Mia XPlat mesh. I have 4 projects here. My Athena parent, my Databricks parent, my Snowflake parent, and my Snowflake child. I did actually build who is this? Harry, using dbt Athena. That's dbt core with the Athena adapter earlier today. Thank you, Jason. And we managed to materialize this into a glue catalog where I can then reference it from within Snowflake. Pretty cool. Now I also built, I want to say Bill, using Fusion. Yeah, cool. Into a Unity catalog where I can reference it using Snowflake. And then I also built a Snowflake model. I think this is Sam, the one we all forget about, into a Snowflake open catalog where I can reference it using Snowflake. OK, that one's like a little less impressive, but it's still sort of cool. It is actually interacting with a real Iceberg REST catalog. So if I look at the lineage for Sophie, here we go. Sophie depends on Harry, Bill, and Sam coming from Athena, Databricks, and Snowflake. And if I go ahead and query this, you can see my 3 catalogs here. This one is actually Databricks, just for those in the know. There we go. I've got Harry, Bill, Sam, and Sophie. Which one is her dad? They're all her dad because I was able to select from all of them. Aw, thank you. OK, some things that are cool here, I think, are the ones that I'm going to talk about in a second. So there were a couple things I needed to do to make this work. I had to build this into a catalog upstream, but in Glue and in Unity, that has the exact same name in Athena and in Databricks that then it does in Snowflake. Okay? That shouldn't be the case forever, but it is the case right now. If I do that, though, dbt gets to reference these tables by their database.schema.identifier names, and it all just kind of works. Bill was built by Databricks and now lives in Unity. Sam was built by Snowflake and lives in Open Catalog. Harry was built by Athena and lives in Glue. They're all my upstream models, and my data could be any of them. OK, in order to make this work, I am using a relatively new and still very cool, but still very new and preview feature of Snowflake called catalog-linked databases. So I can point Snowflake to an external Iceberg catalog, and it will automatically discover which tables are available, which is really important, and refresh its versioned pointers to those tables when new data becomes available. So those were the 2 things that I called out earlier as the real limitations of the single S3 path file-based I know where my Parquet lives approach. I get to reference those tables in Snowflake just as if they're in any other Snowflake database. Within dbt, I can reference them just by their namespace name, which is to say just by writing ref. So that is the realization of cross-project, cross-platform ref. And then when those tables are refreshed in an upstream dbt project, aka the other data platform, they are automatically refreshed in the downstream project and warehouse too. My long-standing dream come to life and the realization of our vision for cross-platform dbt mesh. Let's maybe take a look, because I forgot to look at this earlier, at my child and my catalog YAML here. Nice. OK, so this is what it looks like for each of these catalog integrations. And then because I'm using catalog-linked database in Snowflake, that's the adapter property that I have specified here. But then it can be as simple as saying catalog name to materialize this other model into Iceberg format and write it back to that other catalog, in this case, actually Unity managed by Databricks. So I've given away a little bit of my next piece of the demo here. Who knows who Ruby is in Mamma Mia? I see one hand. OK, what if I told you it's Cher, and she's in the second movie? Who knew there was a second movie? Yeah, OK. That's her. So Ruby is Sophie's grandmother, is Donna's mother. Meryl Streep was busy. So this is my bidirectional cross-platform dbt mesh. I have Ruby in Snowflake. I have Donna in Databricks. And then I will have Sophie, once again, in Snowflake. Let's take a look at what this looks like. And I think just for fun, we can look both in VS Code and then also in dbt Studio. OK, if I save that, let's get some lineage. There they all are. And I actually don't remember if this is going to work or not. Nice. All right. She's not one, but she would probably like to think that. That's OK. So I have, it's not quite as clear here in VS Code, but I think if I go to Studio, it will actually be a little bit clearer, just because of the way that we render the lineage visibly. And let's see if I can update this. Nice. OK, so you can see here at the bottom here that Donna depends on Ruby, Sophie depends on Donna, Sophie also depends on Ruby, but Sophie depends on Donna, who depends on Ruby, right? Ruby is in Snowflake, Donna is in Databricks, Sophie is in Snowflake. That is bidirectional, cross-platform, cross-project DBT mesh. That's pretty cool. OK, there we have it, folks. There's something kind of cool here, which is, Grace, I do need your finger, which is that if I deploy these projects using the DBT platform, I also get to benefit from something called state-aware orchestration that you all heard about a little bit yesterday. Now see, state-aware orchestration is pretty neat because it is, in addition to a way to much more efficiently deploy your DBT project in a data platform, it is also the best way to deploy a bidirectional mesh of projects. Rather than needing to juggle a whole bunch of cross-project job completion triggers, you simply get to say, anytime I build my Snowflake project, build the models that have new data coming from upstream. That upstream can be a source, but it can also be a reference to another public model in another DBT project. So if I go ahead and build these projects on the first go, let's say, again, I correct Ruby's age to whatever it is, I think 70, according to Mamma Mia Wikipedia, not that I checked. Ruby has new data. The next time I build my Databricks project, Donna builds because there's new data available upstream. The next time I build my Snowflake project, Sophie rebuilds because there's new data available from upstream. If there isn't new data available, Ruby is reused, Donna gets reused, Sophie gets reused. I don't need to juggle all of these cross-project job completion triggers. I just have to say, build all of my models in my DBT project that have new data available. OK, this is super new. And most data platforms support reading Iceberg tables from external catalogs, but support for writing back is really still quite rare. Open source engines like Spark and Trino can do this. DuckDB just announced theoretical support for this in version 1.4, but it's like very new, very experimental. There's some kinks to iron out. And the Snowflake feature itself that enabled this, catalog linked databases, is also pretty new. But as these integrations mature, I think we're going to figure out how we can integrate this into dbt's catalogs.yaml abstraction so that cross-project and cross-platform references just work. There's one more thing that we can imagine here, although I won't demo it because I got to keep going, which is what if we can migrate models or even entire dbt projects from one data warehouse to another? If all the inputs to the project are in open storage, and you can materialize the outputs of any project into Iceberg, you can hypothetically build the exact same dbt models using an entirely different compute engine. If I'm using Fusion, as Elias showed us yesterday, I even get dialect-aware SQL validation. This is pretty powerful if you want to try AI-assisted refactoring, like an agentic coding workflow where you try compiling the project, you see that it still hasn't worked, you see which functions have red squiggly lines underneath, and then you try again. And by you, I mean a process that you run inside of Cursor or such. So I could even do this if I have semantic models and metrics in this project, because Metricflow already supports both Snowflake and Databricks as execution engines, and we should see the exact same results because the same data is available to both in open storage. So the moral of the story is it doesn't matter. The data can come from anywhere. They're all my data platform. And thanks to DBT Mesh and Iceberg, the public models are queryable. I have end-to-end visibility across all my platforms. Some platforms even support bidirectional cross-project, cross-platform references. And this is even better with Fusion because of dialect-aware SQL validation, column-level lineage, and state-aware orchestration. End of talk, right? It just works. OK, there's a little bit of fine print here, right? We're in a funny middle zone right now because last year, data warehouse support for Iceberg tables felt super new, super experimental. Today, data warehouses support Iceberg tables more often than not for reads. And catalog integrations are really promising. But you do need to be aware of the caveats. Next year, we might be right back here saying, this is awesome, this is seamless. It works more often than not. Here is a table of what Iceberg support looks like in the ecosystem today. and this is my best effort attempt with some real help from engineers at the DBT Labs team, who I'll give a shout out to later, but any incorrections here are my own. So there's a lot more green up here than there was a year ago, right? Like that whole Snowflake row about being able to to write back to other catalogs via catalog linked databases, that is super new. The DuckDB under construction exclamation point is super new. And again, next year we might be back here looking at a whole lot more green. But the current happy paths are Athena to Redshift via Glue, Databricks and Snowflake bidirectionally via Unity and catalog linked databases, and Athena to Snowflake bidirectionally via Glue and catalog linked databases. Someone just told me that Redshift writes for Iceberg are coming next month. I feel like it's like the new iPhone is dropping. It's like, oh my God, that's so exciting. So this is one thing to be aware of. And then, even when you are in the green, setting this stuff up is pretty tricky. Here are some pictures of me trying to get this working for the demo today. There are a few practical challenges in the near term, and I want to talk through them, but I don't want to spend too much time on this because ultimately I'm optimistic here. So, challenges. Okay, there's a lot of pre-work. Like there's a lot of infra setup, warehouses, storage buckets, IAM roles, et cetera. All this infra needs to generally be in the same region of the same cloud provider. That could be a hard blocker for some. Second, cross-platform primitives like identifier naming and data types are pretty tricky. We have to use the lowest common denominator, which means all lowercase, all quoted, only alphanumeric characters, which means no underscores, and yes, even on Snowflake. Wrangling quoted identifiers has always been really fun there, but it also feels totally solvable. And I think our catalogs.yaml primitive or abstraction can do more here. Third, many of these are preview features. So there's a lot of limitations. If you read the docs on catalog linked databases for Snowflake today, you'll see there's a huge section called limitations and callouts. Warehouses also return really weird errors when things go wrong or they end up in unexpected situations. Failed to commit transaction, metadata file too big, glue into, what do we see Jason earlier today? Glue integration not valid, yeah. These errors can lead to real production incidents in ways that never happened with managed tables in proprietary formats, at least not in like the last decade. So this is something to be aware of. Again, these do feel like solvable problems. It's just going to get better with time. For the quirks and inconsistencies that stick around longer term, I think DBT can help. And for now, this stuff is super fluid. So if you find inconsistencies or if you're the first to read documentation for a new data warehouse preview feature hot off the press, let us know. Our goal is to keep building this stuff, specifically the catalog abstraction, in public as a DBT language feature with support across both Core and Fusion. I'll say it again if you didn't catch it earlier. I built my upstream Athena project using Core. I built all my other projects using Fusion. I could have even built the Core project in Core and then the others in DBT platform. And thanks to the mesh abstraction, it all kind of works. Pretty neat. There's two callouts here that are a little less like near-term tactical challenges and more larger philosophical conceptual. One is permissions. So permissions today in the Iceberg spec, they're not in the Iceberg spec, okay? Permissions are really coarse-grained, not standardized, and not coordinated across compute engines. Like auth is actually not in the Iceberg spec at all. Everything is at the integration or account level, and every data platform then uses its own bespoke system to enforce table-level grants. Snowflake catalog-linked databases for writing tables back to another platform's catalog works super well as long as you are the account admin, as long as you have ownership over the catalog-linked database, and then it doesn't work so well in all of the cases. Now, I do want to give a shout out to the team at Lakekeeper. I mentioned them earlier because they're building a truly open source catalog for Iceberg that you can take a look at, host yourself. And they have some really, really cool ideas about how to implement permissions in a standard way into the Iceberg spec and support finer grained permissions that can then be respected or enforced across different catalogs or compute layers. Okay, one more here is performance. So Iceberg, really cool thing that we looked at earlier is that it decouples physical storage from logical partitioning. But then to achieve performance that's comparable to native managed tables, you do need to store a whole bunch of additional metadata about what data is in which partitions. My understanding is that Snowflake stores a lot of this metadata within its own proprietary compute system, meaning that while Snowflake can leverage that metadata itself, Other data warehouses or platforms trying to read the same Iceberg table won't get the same benefits of that metadata and can't read it as well. I don't think this detracts from Snowflake's serious commitment to Iceberg over the past year. It's just a bit nuanced. There isn't a standard where you write that partitioning metadata to an Iceberg table and then everybody gets to benefit from it. OK, last thing. I know I said 2 more, but actually 3 more. Philosophically. So this year, there have been some critiques of Iceberg as a standard for the ecosystem. And specifically, it's that question we looked at earlier of whether it is correct to co-locate data and metadata in blob storage. So remember, those metadata files are written right to blob storage, right next to the data, so the table can be accessed fully offline. But that direct file access is pretty slow. It doesn't work super well with concurrency. And it's a really distributed approach to storage that feels heavy in the same way that Spark is a really distributed approach to compute that can also feel heavy and pretty slow to start up. So now these data platforms have introduced all these always online RESTful catalog APIs as middleware that can receive read and write requests and then handle the file updates behind the scenes, such that everyone should connect via the REST API rather than interacting with the files directly, except not every engine can actually interact with the API of every catalog. And so there comes a question. Why make the source of truth those metadata files in object storage? Why not make the source of truth a transactional database that's capable of executing transactions at really high concurrency? Maybe I can serve an Iceberg REST API directly from Postgres and skip the metadata.json files entirely. So my understanding is this critique motivated the Duck Lake announcement earlier this year, where you actually store the metadata in DuckDB. And there was also the announcement of S3 tables earlier this year, which exposes an Iceberg REST-like API, but manages a lot of the metadata itself. Even then, I'll just say both Duck Lake and S3 tables support compatibility with the Iceberg REST spec, or with Iceberg, because they recognize that Iceberg is the best, if imperfect, standard that we have in the industry today. Maybe the future of Iceberg looks like it's an open standard. There's a ton of different underlying implementations, but you don't need to worry about those as much as you do right now to get this kind of stuff working. So I do choose to be an optimist here. I think it's a really exciting future. Iceberg has come a long way in the past year. We're not yet in a place where everything just works, but we're already in a place where you can get a lot of cool stuff working. We think Iceberg catalogs provide a powerful abstraction. We are providing an abstraction within dbt for those catalogs via catalogs.yaml. And there's a whole lot more that we think we can build in dbt in the future, like being able to read data from external sources if they live in Iceberg catalogs that we can connect to directly and discover, or making it easier to set up Iceberg than it is right now. Given your catalog.yaml specification, maybe we can go handle some of that infrastructure setup. Or take a cue from the folks at Lakekeeper or other smaller, how do I want to say, easier setup, like one-click Iceberg catalogs just to make it easier to get started. An open data lake that could still provide the tools that managed data lakes provide at scale. So things like automated compaction, partition rewriting, and optimization. My understanding is that the folks at Fivetran have spent the past few years standing this up on behalf of their customers to write data to Iceberg tables directly, and they've improved performance significantly by doing this. There could be, in the future, some integration between that managed data lake and dbt. There are also a lot of exciting proposed extensions to the Iceberg project itself. So not just the kind of philosophical challenge I mentioned about where the metadata gets stored, but also things like table branching. So being able to write select star from catalog.schema.table.branch and then interact with versions of tables directly. That could allow safe atomic create or replace, write audit publish, dbt model versions, who knows? OK, let's come back to the present tense, though. Large data-intensive organizations already adopt Iceberg for cold storage of big historical event data. Extraction tools like Fivetran will land source data into an Iceberg catalog, which is substantially cheaper than loading data directly into the warehouse. Iceberg has real value as an interchange format so that you can share public models across projects and platforms. I don't think we're in a place where every single person should configure every single dbt model to materialize as Iceberg, at least not yet, because managed views and tables are kind of nice, to be honest. You don't need to worry about partitioning or compaction or vacuuming, even up to very large data sizes. I think Snowflake and Databricks and other data platforms have made real good faith investments in Iceberg over the past year, but in a funny way, it does show the value of a managed data platform. It is a walled garden, but it's nice in there. There's a waiter who brings you cocktails, refreshes your drink, makes sure to restock the ingredients whenever they run low. So there's a future dream here where it's easy to materialize every single model in an open table format and thereby unlock complete flexibility and control over which compute you use for every single query. That's going to have to come in the sequel. OK, thank you all for being here. I want to end with a really, really big thank you to the DBT Labs folks in engineering, product, and DX who have kept up with the past year of platform innovation, who built the catalogs.yaml support into DBT, and also helped me with preparing for this demo and this talk. That's Colin, Mila, Anders, Amy, Connor, Jason, Grace. I'm sure there's other folks I'm forgetting, but even some late nights and early mornings this very week. If you are using Iceberg today, or you're interested in talking more about using DBT with multiple data platforms, we're having a roundtable discussion tomorrow at 12:30 p.m. Pacific time in Lotus B as a follow-up to this talk.